So here we are at our next topic. Some of you may be familiar with this, some of you might not, but this is scientific notation. This is why we've learned the exponent laws we've learned. So let's take a look at what exactly scientific notation is. Scientific notation is a compact way of writing very large or very small numbers. This is something that scientists use to describe. This is used when we deal with a lot of planets. Okay, so here's what I need you to understand, and we're going to highlight this really quick. But it's written in this form, okay, right here. See what I'm boxing in? Meaning A, this number, has to be something that is greater than 1, but less than 10. Notice it's also greater than or equal to 1. It cannot be 10, okay? So let's see exactly what this looks like. We can move numbers that are written in standard form to scientific notation, and we move the decimal till it's between 1 and up to 10. And then we write a power of 10, and the exponent is the number of times the decimal was moved. So if you move the decimal to the left, your exponent's positive. If you move the decimal to the right, the exponent is negative. So write these things down. And let's go see this in action. Okay, so standard form. I'm going to change my pen to a darker color so you all can see it. This is standard form. What we need to do is we need to take our decimal. When the decimal is out of sight, place it on the right. Every number has a decimal. If you don't see it there, it's at the far end. But what we need to do is we need to move this until it's a number between 1 and 10, meaning you basically have one place value in front of your decimal. So that's important to understand. So I'm going to write 5.4. Now, if you want to write the 0 after the 4, you can. It doesn't matter because it's on the end. Times 10. Now go back and look. I moved this once. There's one swoop. There's another swoop. So my exponent is 2. And my decimal moved to the left, so it's positive. Let's try another one. Okay, my decimal's here. I'm going to move it 1, 2, 3, 4, 5. Okay? Noticing something, that the number in front of my decimal, there's only one of them. Okay, that's what makes it between where it's greater than or equal to 1, but less than 10. 9.37. Again, zeros at the end after a decimal point are not necessary. Times 10 to the, well, I moved it 1, 2, 3, 4, 5 to the 5th power. I want you to try 3, 4, and 5 on your own. I'm going to look to see if you're understanding the moving. I need to know who's getting it and who's not getting it. But now we're going to shift gears a bit, and I'm going to come down here. The rule doesn't change. I have my decimal point here. I'm going to move it 1, 2, 3. Again, I only want one number in front of my decimal, so that I have 9.82 times 10 to the, well, I move to the right. And I move 1, 2, 3 times. So if I moved right, it's a negative. Let's try this again. I'm here. 1, 2, 5.273 times 10 to the negative 2nd power. Okay, So I want you to try 8 and 10, 8, 9, and 10 on your own, okay? So pause and try those. Because if you can try those, and I can see those, and I'm going to look, because you cannot move on the rest of this week or even into next week if you don't understand. So you have to know what scientific notation looks like. So with that being said, are we in scientific notation here? And here's what I look for. Is there one number in front of the decimal? Okay, there is. Is there a base of 10 with an exponent? There is. So yes, this is scientific notation. Let's come over here. Here's my decimal. But this number here is 11, meaning it's greater than 10. So I'm not in scientific notation yet, so we got to get it there. If I take this and move it left once and have 1.14, I am in scientific notation. But I move left once, and there's already a 3 there. So I'm moving an extra space, so really it should be to the 4th. Oh, they went over too far. So if you look here and I move back 1, I get to my 8.51. Now, with 12, we added to the exponent when I move left. But here, I'm still going to add to my exponent, but I'm adding to a negative. I'm adding 1 because I moved 1 space to a negative, so it got smaller. And if I look here, there's one number in front. This is a yes. So ladies and gentlemen, it's just going to take some practice. You got to know how to move and what scientific notation looks like to do these problems. So that's taking a number in standard form and making it scientific. But what about scientific to standard? Well, that's even easier. So here's what we do. We take the exponent. That tells you basically the direction and number of spaces. Okay, meaning a positive exponent, we're going to move right. A negative exponent, we're going to move left. So make sure you have that down. Think of your number line. Positives are on the right, negatives are on the left. So here's what I recommend. I recommend writing this down because really you're on a computer screen. I'm going to move 3 times and I'm going to move right because it's positive. So I'm going to take it here and go 1, 2, 3. Now there's this extra space here, meaning I have to add a 0. So standard form was 6,380. Let's try the next one. Write down your number. Take a look here. This means I'm going to move right. Write this down also. But I'm moving right 5. 1, 2, 3, 4, 5. My decimal's here. There's 2 extra swoops. Okay, so I've got it. Now I have to have those zeros. This is different. The decimal's over here. So these zeros are required. So it's 208,500. This one's not too hard. Okay, it says I'm going to move it once to the right because it's positive. So I'm going to move it once to the right. Okay, so I want you to try 18 and 19 on your own because I want to jump to 20. I want you to take a look here. This is a negative. So that means my decimal is going to move to the left. Okay, so what does this look like? I'm moving left 5. Here's 1, 2, 3, 4, 5. Each swoop is another 0, and you must have them. Now they must be there, because here's my decimal point, right? And there were 4 zeros that I just added, and then my number. Okay, let's do this again. Here's a negative, meaning I'm going to go to the left with my decimal. So I take 7.932, and I move it once left. So this time, I just end up with 0.7932. That might happen sometimes. Let's look at this one. -7 left. So we're going to be moving left, so I'm going to move this over here a bit. So here we are. 1, 2, 3, 4, 5, 6. And that means I'm putting in all these extra zeros. Okay, but remember I'm going 7. So this one counts. So if you see here, 1, 2, 3, 4, 5, 6, I actually need to go over one more. Okay, meaning there are 6 zeros and then my number. So please try that here on 23 and 24. So I'm going to look at the 2 that I wanted you to do, okay, here on 18 and 19, and the 2 here. Why is this important? Well, we need to be able to compare numbers. And when you look at these numbers as they are, you can't decide what their values are. Some people say, oh, I'll just get a calculator. Well, this would be on the non-calculator day. So the best way is to take each number, so 7.42, and move it 3 times because it was positive. So I have 7,420, right? Now if I come here, I move it 5 times. 1, 2, 3, 4, 5. I gotta add my zeros. Well, really, this one is greater when you look at it. So just looking at that decimal part is not going to tell you which one's greater or less than, because we're dealing with multiplying by a base of 10. Okay, so I want you to try these 3 using the skills we just did. Last but not least is our application, okay? So all they want you to do is take this number and write it in scientific notation. So I need it to be between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's got to go here. Okay, now I moved my decimal to the right. That's a negative. Here's the thing. If your standard form starts as a decimal, if your standard form is a decimal, okay, then your exponent is negative. If your standard form is a whole number, then your exponent is positive. If I were you, I'd write that down. So this one's a little bit of a challenge, and I want you to attempt it, because they're telling you that this is how far Earth is from the sun, and this is how far Mars is from the sun. They want to know which planet is closer to the sun and by how many miles. So, but your answer must be in scientific notation. So your first step is to find their distance, find their difference, And then last, convert. I want you to try this, and we're going to go over it tomorrow. So this was kind of quick, but it's very basic. Remember, you have the ability to pause and rewind. I'm going to be looking at the problems I asked you to do. If you have any questions, let me know.